Let's talk about what is, without a doubt, the single most important invention of the 20th century. Now, you've probably never actually seen one, but I guarantee you were using billions of them this very second. We're talking about the transistor, the tiny, totally hidden engine that runs our entire modern digital world.
Just look at this number, 100 quintillion. I mean, that's a number you can't even really wrap your head around. And that's the estimated number of transistors that have ever been made. That's way more than all the grains of sand on every beach on Earth. It is, by a long shot, the most produced object in human history. It's just staggering.
So, what is this little thing? This almost invisible invention that is the bedrock for everything from our phones to our cars to the satellites orbiting the planet. Let's peel back the layers and get right into it.
Okay, so how do we get our heads around something so small but so important? Don't worry, you are not going to need a degree in electrical engineering for this. Turns out all it takes is a really simple analogy to understand exactly what a transistor is doing.
So if you look it up, you'll see the formal definition. It's a semiconductor device used to switch or amplify electronic signals. Now, the two key words you really want to lock onto there are switch and amplify. Those are basically its two superpowers. But before we get to that, let's find an easier way to picture what's going on.
Let's just forget about electrons in silicon for a minute. By far the easiest way to understand a transistor is to just think of it as an electronic water faucet. Seriously, it's the perfect way to visualize its main job.
And this is exactly how it works. You've got the handle of the faucet. In transistor speak, that's called the base. It's what receives the small control signal. Then you have the main water supply, just waiting in the pipe. That's the collector. And finally, the water that actually comes out, that's the emitter. The whole point is that a tiny little turn of the handle controls a much, much bigger flow of water.
All right, now that we've got the faucet analogy down, let's switch that back to the world of electronics and see what's actually happening with the electrical current.
So let's just replace the water with electricity. The base is still our control. It's the faucet handle. The collector is the input, where the main electrical current is just waiting to go. And the emitter is the output, where that current flows out from. But, and this is the key, it only flows when the base gives it the green light.
And this right here, this is the secret sauce to everything, all in one sentence. A tiny little electrical signal sent to the base acts like a gate, opening up to allow a much, much larger flow of electricity to pass from the collector to the emitter. That's it. That's the magic trick that completely changed the world.
And you know, this one simple principle gives the transistor two completely different world-changing jobs. You can think of them as its superpowers, the ability to be a perfect little switch and the ability to be a powerful amplifier.
So its first superpower is acting as a flawless electronic switch with no moving parts. It's simple. If you send no current to the base, the faucet is off. The main current is blocked. We call that a zero. But if you apply just a tiny current to the base, bam, the faucet turns on and the main current flows right through. We call that a 1. Zeros and ones. Sound familiar? Yep, this is the binary language of all computers, and transistors let us speak it at truly unbelievable speeds.
But it's not just an on or off deal. Its second superpower is just as important, amplification. This is where we're not just turning the faucet on or off, but we're controlling exactly how much it opens.
This chart shows the idea perfectly. Imagine you feed a really small, weak signal into the base. Think of it like a faint whisper from a radio antenna. The transistor uses that tiny signal to control the much bigger current flowing through it, and what comes out the other side is a much stronger but identical copy. It literally takes a whisper and turns it into a shout.
So we have this incredible microscopic switch and amplifier. But how in the world did we go from this one tiny component to it being the foundation of our entire civilization? Well, let's connect the dots, from a grain of sand all the way to the smartphone in your hand.
So where did this thing even come from? Well, it all started back in 1947 at Bell Labs. See, before the transistor, the first computers used these huge, hot, unreliable glass vacuum tubes that were constantly burning out. The transistor was a total game changer. It was tiny, it was solid, and it was incredibly efficient. This was the breakthrough that let electronics shrink from the size of a room down to a tiny chip where we can now pack billions of them.
And the result of that incredible shrinking act is, well, the world all around us. Our computers, our phones, modern medicine, space exploration. Pretty much every single piece of advanced technology you can think of is only possible because we figured out how to make billions of these perfect microscopic switches and get them to work together.
So just think about this for a second. The next time you tap on your phone screen, every pixel that lights up, every calculation that happens in the background,
every sound it makes, it's all happening because millions of these tiny faucets are turning on and off, thousands and thousands of times every single second. It's amazing. At the end of the day, the transistor took simple silicon, which is basically just purified sand, and turned it into a thinking rock, laying the foundation for the entire information age. It really makes you wonder, right? What's going to be the next everyday material that we transform, one that completely redefines the world for the next generation?